Okay, we are looking today at trigonometric relations. We're going to be using the unit circle a little bit. So I'm going to show you how to make simple proofs using the unit circle. That's our first goal. So we have a bunch of formulas here for supplementary angles, and we wish to create a proof. So the first thing you need to do for any of the proofs is you need to draw a diagram. When we draw our diagram, we need to look at what angles that we have here. So we have sine theta here, so we need to include theta in our diagram, and then we label the points A and B. Next, we need to see what other angles we have. We have an angle which is 180 minus theta. So where is that? If we rotate by 180 degrees from 1, 0, where will we end up? Well, if we rotate from 1, this is 1, 0. If we rotate from here by 180 degrees, where do we end up? Let me take, yes.
-1, 0.
We end up over here at negative, so this is where we end up with 180. Then if we rotate backwards by theta, if we rotate negative theta, we go slightly backwards like this one. We need to label this as minus theta. So what we need to do now is we need to put the point Q, and in the point Q we need to figure out what the coordinates are. Discuss or explain to the person next to you, what are the coordinates of point Q? To the person next to you. Yeah. All right. So can somebody give me the answer there? Let me take your answer. Negative a comma b. So that's the coordinates of Q. So that's our first step. One thing to help you with this is when you draw your angle on the unit circle in your sketch, draw it with an angle of about 30 degrees. Don't do 45. It's much harder to do it with 45 than it is with 30, because what you get from that one is you get one side which is shorter and you get one side which is longer. And this will help you with the reflections and the rotations, moving it around and figuring it out. That short side has the length A. That longer side has the length B. And obviously, if we're drawing it in this direction, in the vector space, it becomes negative B. So now we've got our diagram drawn. We can use this diagram to create our proof. Our job is to show that sine 180 minus theta is equal to sine theta. So we start off on the left-hand side. That's what this symbol means. It says the left-hand side of the equation I'm going to prove is, and then we copy it down, sine 180 degrees minus theta. Now, using the unit circle, a sine value, is it the x value or the y value?
Y.
A sine value is the y value. So at point Q, what is the y value? B. So at point Q, the y value is B. And we're using point Q because we're talking about 180 minus theta. Now, if we're talking about theta, the right-hand side has the sine theta. So what is the sine value at point P? It's also B. This proves that these two are the same. This is also B. This is sine theta. Now we're there at our final answer, sine theta. This is the right-hand side. Done. That's it. We've shown the first one. Have a go now at trying the second one. Have a go now at trying the second one.
Isn't it negative theta or 180 minus theta?
If we label it here as negative theta, or we can label it like this as 180 minus theta. So this rotation is 180 minus theta. You don't need a new diagram for this second one. You can use that diagram.
Which one is the second one?
The second one is the cosine one. So let's have a go at showing this one. I'll come around with the red pen of success. Put your hand up if you think you've got it. of success, anyone? This is good. No. Well, this is the. You don't know the left and your right. This is the left. This is the left. This is the right.
Yeah.
Okay. Yeah.
So do you have QED as well?
No, not for left hand side, right hand side. It's a bit over. You're missing you're missing, yeah, you're missing this isn't the left hand side, it's the right hand side. This isn't, you don't say what's that, this is you get left hand shape. This is good. Alright, let's move on. Left hand side. So if you're trying to show the equation, so you've got show the cosine of 180 degrees minus theta is equal to minus cosine theta. That's the question. So you start with the right hand side of this equation is 6. And from the unit circle we see that that is minus 8. Thank you. This is minus 8. That's equal to minus theta. That's actually equal to the right hand side. We do it on the board. Okay, let's do it on the board. So we start off with the left hand side of the equation we're trying to show. That's this. We've got the cosine of 180 degrees minus theta. We turn to point Q. And at point Q, we see that the cosine value is minus A. We then go to point P. At point P, we see that the cosine value is A. So minus the cosine value is minus A. So that's what we've got here. We've got minus the cosine of theta is equal to the right hand side. These are the supplementary angle theorems. We'll move on. Take questions?
Aren't the variables supposed to be switched? Because for sine we're supposed to find A. Because on the diagram we put sine as A.
The diagram, the circle, you said the Y.
For point AB.
Ah, right. I'm with you. Yeah. You mean I've got these bits wrong. Yeah. So the sine value, I'm afraid, is B. The sine value here is B. The cosine value is minus A, and the cosine value is A. Yeah, thank you. We don't need to show those ones on the diagram. All right. So complementary angle theorems. Let's have a look at the first one. The sine of 90 minus theta is equal to sine theta. So the first thing we need to do is see which angles are involved in this question. We have theta involved, and we've already got this one drawn. So what we need to start with is we need to do 90 minus theta. So what coordinates is 90 degrees going to have the terminal side end out?
0, 1.
So here at 0, 1 is where 90 degrees is. So we go up in this direction, and then we rotate back theta. So we're going to get minus theta here. So the angle 90 minus theta is this one. This angle here is 90 minus theta. So what are the coordinates of point Q? Discuss with the person next to you. What are the coordinates of point Q? Let's have a look. So the coordinates, this line here, the short line, is how long? This is B. This is the short side. So how long is this one? B. This line here is A. How long is this line? A. So the coordinates at Q, what is the x value at Q? That's the green one, isn't it? B. What is the y value at Q? A. So the coordinates here are B, comma A. We'll use our diagram to make our proof. Left-hand side is equal to sine of 90 degrees minus theta. Now, the sine value at Q is what? A. And at P, A represents what? The cosine value. This gives us cosine of theta. So this is equal to the right-hand side. Have a go now at doing this one for yourselves. Put your hand up when you're ready. I'll come around with the red pen of success. Nice. We're doing one mark. All right. What? Let me tidy up my diagram a little bit. This works. All right, let's have a look. So you can you're getting it right, but you guys are missing a little bit of the formula. So we've got the left-hand side is equal to tan of 90 minus theta. This is equal to the sine of 90 minus theta over the cosine of 90 minus theta. And then at point Q, what is the sine value at point Q? Is it in?
The sine value would be A, yeah.
The sine value is A. What is the cosine value here at this one? B. So A over B at point P. So what does A represent at point P? No.
A is the cosine.
So at point P, A is the cosine of theta. At point P, what does B represent? This represents the sine of theta. And this is the definition of cotangent of theta, which is the right-hand side.
A and B for Q.
At the
I
back.
can't write A over B or B over A. Do we apply the cosine of theta and over sine of theta?
Mine explains it a little. If you cut off, so a few of you have not included this bit and this bit, and then made your proof looking like that, which is technically correct, but you're not really showing it in sufficient detail. Because you're not showing the connection between the unit circle and the letters A and B and where they're coming to these formulas. There's an extra step that's going through in your head because that's how you've done it. You have to show the extra step. So sometimes some of the harder proofs are showing the simplest of things. Showing things that are really easy can get really hard. One of the questions they tend to ask at like Cambridge interview is to explain why 1 + 1 is 2. And then you have to rely back onto fundamental algebra, and that becomes really tricky.
Will we get wiped down if we don't include some of the proof?
If on any solution you don't include some of the solution, yes. It's like if you say something is true, if you say something that is true, it doesn't make it true unless you have the evidence to show it. And that's what it's all about. All right, let's try another one. These are the complementary angle theorems, whole collection of those. Negative angle theorems. So, first step, let you guys have a go at this one. So try this one for yourselves. Try this one for yourselves. Draw your diagram. Draw a fresh diagram. Don't add it to previous ones because I need to know exactly which parts of the diagram you're talking about. So for any of these type of proofs, a fresh diagram. Draw it large enough so we can see the angles. Should be at least sort of 6 lines of your book big. Try and get your lines a little bit more horizontal than vertical, and try and grow a little bit. Okay, so where is minus theta going to be in the diagram? This is not minus theta, is that rotation is theta? It's also in the wrong place. So your rotation needs to be negative theta from the initial starting point, which is this one. You're going to be in the 4th quadrant. So let's look at the diagram. So good. This is very hard. It's very good. It's still a little bit bad. But otherwise, why don't we have it go? So the second one I'm going to ask you to do is this one. So your diagram is going to be bigger than this. How do you label this as being negative theta? And it's wrong. And here in this one, you're missing something. Oh, that's what you're trying to show. Show that. So and then here is where your left hand is showing. What is this? So this is yeah, it should be an equal sign. Sorry, let me come down this row here. Do everybody here? You need a diagram. It's no good without a diagram. It's worthless without a diagram. None of your work. without the diagram, you'd be not referring to anything. You've got no evidence that you're. So I could prove anything I want. So using your strategy, I could prove that the tan of 3 theta equals tan theta. So I'll do a left-hand side. This isn't actually true, but if I use your technique, without the diagram, your proof is meaningless. You could prove any Holder Roche. These type of proofing techniques are used by politicians. All right, let me do this one on the board. So what we need for this one, is a rotation of minus theta. It means we move clockwise in this direction. It makes point Q have the coordinates a comma minus b. So we're asked to show this. The left-hand side is equal to sine of minus theta, which is equal to, for point Q, the sine value here is minus b. Now we look to point P. The sine of, at point P, sine of theta is b. So we're going to have to multiply that by minus 1 times the sine of theta, which is equal to minus sine theta, which is equal to the right-hand side. You don't necessarily need this extra step here. I wouldn't feel that about. So we're going to have a go now at question 2. Question 2, we need to show this one. So the left-hand side is equal to the cosecant of minus theta, which is equal to 1 over the cosine of minus theta. What is the cosine of minus theta at point Q? What is the cosine of minus theta at point Q?
Cosecant for sine.
Oh, sorry. Yes, you're right. 1 over sine minus theta.
Is it?
What is the sine value at Q? What is the sine value at Q?
Negative b.
Negative b. So we get 1 over minus b. Okay, then we look at where are we going with this one? So we're going to be going to that one. So this is equal to minus 1 over b. Now 1 over b is the cosecant of theta at point P. So this gives us minus the cosecant of theta, which is equal to the right-hand side. All right?
Would we need to say that minus 1 is equal to 1 over that minus 1 over sine?
I think that's a little better, isn't it?
Yeah.
I think that's a little better. All right, take a minute to copy them down. We'll just quickly do the register. Why is the advanced class healthier than the IM3 regular class?
I know. Actually, eating healthy actually makes your brain healthy to its strength, and so therefore you would be more likely to get into this class.
I think it's more social. I think it's more about who skips school easy. Anyway, it was a nice answer. I liked it. It sounded very, very accurate and scientific. All right. Have a go at this one for yourself. Does that also link to why attendance goes down when there's an exam on? Something about even before an exam?
It's just a correlation.
Oh, there's a strong correlation
They have to feel this.
on the day off.
Yeah.
For the exam.
Foolish.
Okay.
Because the retake version is always harder.
Yeah, what if I told you? The retake and it's 10 times harder.
Yeah, don't do that.
Why did they do that for?
To show if you like pretend you're 6 and then like.
We can only write so many questions. So we, if we were having to write a lot of questions, you got to piece them out. Maybe the better questions go onto the test that most people get, and the not so good questions go onto the ones that is only used by 1 or 2 people.
Another thing is maybe you would have had more time to study even if you were sick. So is that a factor?
Draw your diagrams, David. Draw your diagrams.
How is even possible that cosine of this is minus a comes to
This is the short side.
oh, this is the short side.
It's the written switch.
It's all about the diagram. The other bit's easy. Where are we? Sorry. I'm trying to go around this many different things as possible. All right, let's look at the diagram. The diagram is the most important part. So we need to find 90 plus theta. That's going to be up here. So there's our short side, there's our short side. Our short side is b, this is minus b. So our coordinates up here is minus b comma a, here at point Q. So to make our proof, left-hand side is equal to the cosine of 90 plus theta. That's this, point Q. The cosine value is minus b. Now over at point P, minus b, well, b represents the sine value. So this would give us minus the sine value, which is the right-hand side. Okay, we good? Let's try this one. to draw lines with a single stroke of the pen. Yeah. You definitely get one of these type of questions on your test. There are infinite number of possibilities I can make. They're very easy to do, one for each version. Perfect test question. It's a simple proof as well.
So it's sent.
Do you have to prove a lot of things or just answer questions?
Mostly answer questions, but we'll have one of these, and then we'll have one harder proof. The harder proof will be from analytic geometry, involving typically all of the proofs on the course are Pythagoras' theorem. So if I ask you to prove the distance formula, Pythagoras' theorem. Prove the circle's equation, Pythagoras' theorem. Prove the cosine law, Pythagoras' theorem. It's all Pythagoras' theorem and unit. Yeah, they are, but it's the same basic methodology behind it. Once you start seeing a few, you start getting better and better, like this. What are we looking at? Let's see what we're there. That looks good. That's easy. The diagrams are hard part. Good. Good. This is short. Where did I
Okay, I just organize
Seems inefficient to you. You should be playing mobile phone more and not be writing letters. It's good enough the first time you're overachieving. Yeah, you don't know the angles. Which diagram do you want me to look at? Really? Yeah. I get there eventually. It's wait. What am I thinking? I've already done this.
No, that's fine. This one we're doing. You already did this.
Right. I haven't seen this is negative. This is negative. These are backwards rotations in this direction. Your diagram is too small. Diagram is correct when you prove it correct. It's easily a bit bigger so you can show it more. I've done to you in your test. I haven't seen you. So here, it's impossible to read what's written inside there. So, what about there? No, we need to see what it says here and here. I think it does say minus theta ever so slightly, but you are having to use such a light stroke of the pencil because you just not left yourself enough space. Otherwise, it's good. All right. So we need 270 minus theta. That's here. We need to show theta in that direction. That's minus theta. So that's minus theta there. We need another one up here. This rotation here is also minus theta. So here we have 270 minus theta, and the coordinate of Q
Minus b comma a.
is going to be minus
Minus b minus a.
b minus b comma minus a. R up here is going to have the coordinate minus a comma b. So let's build our proof. The left hand side is equal to sine 270 degrees minus theta. So the sine value at point Q is minus A. At point P, minus A is the cosine value, which is what we want. So the cosine of 100, sorry, at point R, the cosine value is minus A, which is the right hand side. Definitely get one of these tests on one of these proofs on your major. It's a nice easy one. Make sure you have a ruler and a pencil. Some of your drawing skills are lacking. And as you see on this one, it's all about the diagrams, how you draw the unit circle.
If you get the diagram wrong, will you get the answer?
Yeah. No, the answer's wrong without the diagram. Like I showed earlier, I could make some rubbish up and show that it's true just by writing things down.
We drew the diagram, but it's a bit.
There's only so much. If you look at one of these proofs, this sentence here, this is given. All of this is given. You've got a 25% chance of this being right with no knowledge. You've got two letters and plus or a minus. It's a 25% chance of just randomly writing the right thing there. It's the diagram that carries the weight of the evidence. Okay, I am going to introduce radians now. Are we ready? We're not going to see too much. So we look at the unit circle. What is the angle here at point 0, 1? What is the angle of rotation here at this point? Let's see some hands. This is 90 degrees. What about here at this point? What is the angle here? 180.
270. Yeah.
What is the angle here? It's not 270.
0.
Here it's 0. What about here at this side of the line? This is 360 degrees. And how about here at the bottom?
270.
270.
You like skepticism.
Why not?
That was the point. Sorry, all out.
Answer the question. Wait for it. Why is there 360 degrees in a circle? Some guy decided it would be.
I know. Because it's a very divisible number.
And he chose this number because it's a very divisible number. It's divisible by almost everything. And also, he was working in his entire math education in base 60. So it fits nicely to base 60 as well. And they decided 360. And 2,000 years later, we're still using it. Is it correct? No, not necessarily. About 200 years ago, the French decided that this isn't decimal. So we will have 100 degrees, we will have 100 gradients in every sector. So 400 gradients in a circle. So they decided to use the same kind of system, but let's make it, standardize it up to a 400. And you can find that setting on your calculator, gradients. And it is used quite a bit, particularly in artillery. I had a friend, a math teacher friend, and he, when he did his military service, was a captain in the artillery for the Swedish army. And he said that they use gradients because it makes the calculations much, much quicker. And that makes sense, because 200 years ago, the French would have been heavily involved in the Punic Wars, using cannons all the time, and making quick artillery calculations is useful. So math serves a need there. However, this is not the right amount of sections that we should cut a circle into. In mathematics, we find a bit later that if we use 2 pi sections in a circle, it simplifies a lot of the mathematics. So you're going to discover some mathematics next year and the year after, that when you're using radians instead of degrees, all the formulas become a lot easier. All the formulas. So a circle is going to have 2 pi radians. So how many radians in a semicircle?
Half pi. So the semicircle is pi.
A semicircle is going to have pi. What about 90 degrees? How many is 90 degrees equal to? I like to say pi over 2. What about 270?
Really high over.
2 pi.
Let me show you how to do this when you're right here. So in 90 degrees, how many radians? Pi over 2. Pi over 2. How many 90 degrees to get you to 270?
0.
From 0, how many 90 degrees?
3.
So we have 3 lots of 90 degrees. You'll make a lot of calculations between a few different bits and pieces. So just doing a quick table. So normally in our exact value table, we use this pattern. This one's pi over 2. This one's pi over 2. How many 90s are in 180? How many 45s are in 180? How many 60s are in 180?
3.
How many 60s are in 180? I'm not going to go for 180. How many 30s are in 60? So we halve this one. In other words, how many 30s are in 180? 6. So the fractions work a little bit like this. That's all we need to know about radians and all we need to use with them for the homework exercise. I've got a homework exercise that introduces radians once you get your smart score over 80, just for the last few questions. And it's a nice, I thought it was a nice introduction to the topic, and we'll see it more later. Let me show you this one. We need to solve this equation. How far? A flip? Flip. That would have been great, wouldn't it?
Yeah.
I wish. You can, yes. You jumped ahead. Okay, can we go forward?
Yeah.
I should drink water a second. Okay. Let's have a look at this question. This question looks really, really hard. It is not. If I flip back to my formula sheet and I go back to here, if I look here, it says if the secant of angle x is equal to the cosecant of angle y, then they're complementary angles, meaning that they have a sum of 90 degrees. Here in this formula, it says if the secant of an angle is equal to the cosecant of some angle, then those two angles are complementary. Let me show it in a different way. So, if the cosecant of x is equal to the secant of y, this implies that x plus y equals 90 degrees. That's it. That makes this question easy. So we see in this question that the cosecant of some angle x is equal, let's say the cosecant of some angle y is equal to the secant of some angle x. So this equation, let me do it like this. So this equation implies that 4 pi over 3 plus x is equal to, what is 90 degrees in terms of radius? Pi over 2. So x is equal to pi over 2 minus 4 pi over 3. So now we need a common denominator. What would that be? How do we make pi over 2 into 6? 3 pi over 6. How do we make 4 pi over 3 into 2?
8 pi over 6.
We multiply top and bottom by 2. We get 8 pi over 6. What is 3 minus 8? Notice how I'm looking at this. I'm looking at this really simply. I will add in an extra line here. So when I see fractions like this, they're not as hard as they look. This is pi over 6 multiplied by 3 minus 8. I don't have to write this. This is what's going through my head. When I'm doing that subtraction, I'm subtracting 8 from 3. This gives me minus 5 pi over 6. Look for any simplifications at that point, but 5 is a prime number and 6 doesn't have any factors that are 5. This is our answer. That's it for today.